Hey, welcome back to the shop. So today we are going over pumps in our hydraulic systems. Now with pumps there are basically two kinds of pumps. You have your positive displacement pump and you have a dynamic displacement pump. Now dynamic displacement pumps basically use flow and velocity and kinetic energy in order to create the pumping action, or to help with the pumping action. The pressure is at a variable rate. Normally with these pumps you'll see them in water pumps, bilge pumps, things where you don't need to meter the flow. So it's just pumping fluid. Now positive displacement pumps, those basically move the fluid by dividing the fluid into metered proportions, metered volumes, and then creating that flow through the system. And those are where you're going to see in hydraulics and HVAC. It's all a metered flow. Basically, because it creates a metered flow, it reduces the amount of back pressure in the system, so that way it can create the needed pressure on the front part of the system. And you lose none of that pressure, so there's no loss of pressure. In a dynamic pump, if you tried to use that, there'd definitely be a loss of pressure. You wouldn't be able to get enough pressure out of the fluid in order to do the actuation that you need. So, like I had said in my previous video, there's three types of pumps that are positive displacement pumps that we use in a hydraulic system. The first one I'll show right here, picture from us working on it, tearing apart. This is a vane pump. Now this particular pump could be used on power steering. The vanes in this pump are pretty much extended by centrifugal force, so the spinning action will cause the vanes to slide out. And in some vanes there'll be a spring retainer, and that will keep the vanes pushed out to the sidewall, but this one uses centrifugal force. Now the next style pump that we have is the gear pump. Let me go back to the vane pump. The vane pump usually operates at about 2,000 psi. That's the working pressure, and as I talked before, working pressure is like the burst pressure. That's the pressure that it'll operate at until a fail point. So the next pump will be the gear. So the gear pump operates at approximately 2,500 psi. That is its working pressure. Usually with the gear pump, it's a fixed displacement, meaning that there is a metered amount that'll come through you. It will never be more, it'll never be less. It'll be that same amount, utilizing those gears. So the picture here, you can see the gears, how they go together, and how it would push it through, push that metered amount through. The last we have, which I'll try to get a picture up here if I can, it's going to be the piston pump. Again, metered amount of flow. Now this piston pump operates at a higher pressure. It's about 5,000 psi, which is the working pressure. That's its limit. The pump for the piston is actually, how do I put it? It gives you consistent pressure. So it operates at high pressure. It gives you that consistent pressure. There's no back pressure. This one you're going to use when you're utilizing heavy equipment, things like that, where you need a lot of pressure delivered to the actuators when you're digging or hauling or moving any large amounts. So when you want that consistent, constant pressure, you're going to usually use a piston pump. So those are the three different types of pumps. Rather simple, not much to them. Here we pull them apart and pretty much take a look at the insides. There's not a lot to it. Now the piston pump is a little bit there's a little bit more to it. There's more parts because you have a wobble plate, basically an offset plate that as it spins around, it creates the pistons to go up and down. That's how that meters the amount and is able to deliver such high pressures. We see this in HVAC systems. The HVAC system can use a piston pump, and I had taken one apart previously, and you can see how that delivers such high pressures, and that operates using almost like hydraulics. It's a gas, and so it pushes the gas, and so that it works really well because those pressures can get up to about the operating PSI was 200 PSI for that particular gas, which is really good, and it can get higher. So thanks for joining me, and in our next video we're going to go into valve and valve bodies. So stay dirty.